What is the name you told?
So my name is Ravi.
Ravi. So Ravi, how you are finding science in your school? How they are teaching?
So I am good in science, and science is very interesting subject. I like science.
Yes. So you find the teachers are good. They try to explain your doubts.
Yes, sir, always.
Okay.
So I have one doubt.
Yeah, sure. Please go ahead.
What is the what is the law of Newton? Second law of Newton.
Acha, that's a very good question, actually. Yes. But do you know what is the first law?
Yes, force of inertia.
Yeah. Yeah. In simple terms, suppose you want to explain this to someone, a kid younger than you, then how will you explain the first law?
Mm, I gave two example.
Hmm.
A bus can move, and we see a object. Um, Force of inertia. Every object in the. So give me
Okay.
1 minute for revise
Yeah,
my topic.
I will tell you in briefly. So
Yes, sir.
briefly, this Newton's first law is a very interesting law in the sense that people from hundreds of years before they were thinking that why something moves, what makes it move, because there was
The
no
force of
concept.
inertia.
No, I mean, okay, whatever you say, why something moves. That was the main question. So Newton came with this first law that in this world nothing moves. Nothing moves unless a force is applied. Now
Yes,
it
sir.
is known to all of us, we are reading in schools, but in those times, this was a very new concept. You'll be
Yes,
surprised.
sir.
In, say, 2000 years back, there were people who asked that when I throw a ball upwards, why does it come down? So nobody could answer that question because they did not know what is gravitation and all these things. So they used to say because it has to come down, so it is coming down. There was no explanation. People were never satisfied, but all the educated people said so, like Aristotle. So people accepted because he was very respected person in Greece. So Newton came up with this idea. This that in this world nothing moves unless a force is applied on them. So everything, like say, suppose you have kept a ball somewhere, and suppose
Yes,
next
sir.
day if your ball is not there, that means some force must have come and the ball is moved. I'm telling a very simple example. So he said very straightforward way that unless a force is applied, nothing can move. It will remain in the same position as it was forever and forever.
Yeah.
So it is after a force is applied, then something moves. Now, second law is a consequence of the first law. Second law is a consequence in the sense that if the force is responsible for something movement, then what is the equation? One means how much how much it moved. So he came up that force acceleration is proportional to force. If any force applies on anything, the acceleration takes place. And he told force is equal to mass into acceleration. First law he
Yeah.
said without force nothing can move. Second law he quantified. Means he made it that you can calculate anywhere, everywhere. Of course, when you read relativity, the equations get little bit modified, but because mass is a changeable product. But in those times, that was not there. So, second law says very simply that force is proportional to acceleration, and by twist of something, you can make that constant as mass into acceleration. So
Yes, sir.
So this was a very interesting. The third law is still more interesting, but I'm not answering now.
Yes,
If you
sir. Third law example, pull a ball. Sorry, push a ball
Mhm.
and answer firing.
Yeah, to every action there is always equal and opposite reaction. It's very interesting. It is
Yes, sir.
one of the very important laws, but very wrongly misunderstood at times. So, like
Yes, I got it.
a rocket when it goes, it throws out, say, whatever fuel in that, and the rocket moves forward. Or suppose the Earth is attracting the Moon, then Moon is also attracting with the same force to the Earth.
Yes, sir.
Equal and opposite reaction.
Force of gravitation.
Yeah. So my question to you is that if the Earth is attracting Moon and Moon is also attracting Earth with the same force, why the Earth doesn't move towards Moon?
Because sir, sun gravitation force.
No, not because of
Sun.
sun acceleration, because the mass of the Earth is so large. So same force is same. So mass into acceleration. So if the mass is more, acceleration will be less. And
Oh,
if the
yes,
mass
sir.
is less, acceleration will be more. So if you throw a ball from top to down, so ball is also attracting the Earth with the same force. But the Earth doesn't move because the mass is very large. So this is very
Mhm.
interesting law, but the people before Newton didn't know this.
Yes, sir.
So are there some more questions? We have another question. Yes, go
Yes,
ahead.
sir.
You're Saksham, isn't it?
No, sir, I'm Aryan.
Huh?
Sir, I had a question. I'm Aryan. Hello.
You're Aryan. Hello,
Yes, sir.
Aryan.
Yes, sir.
Okay. Yeah, I didn't see your photo, sir.
Yes,
No,
sir.
but
I
you
joined.
are in a different name.
Yes, sir.
Sir, I am Saksham.
Yeah, you're Saksham. I know that. Yes. Sorry, Aryan. Yeah. Yes. Yes,
So,
Aryan, what is the question?
sir, according to Newton's third law,
Mhm.
we should not be able to lift any weights.
We should not be able to.
Lift any weights,
Why? No,
sir, because
if
there
the,
is an equal and opposite force.
hmm.
So why can we lift things?
No, so whatever, suppose there is a book you are holding in your hand. The
Yes,
book
sir.
is applying a force.
Yes,
Book is applying a force downwards, and your hand is applying a force upwards.
yes, sir. So, but you said that there's an equal and opposite reaction of force to that.
No, no, equal. There is a equal and opposite reaction, but there is a suppose you are holding the book,
Yes, sir.
then comes equal and opposite. When the motion is there, then that's another issue.
Okay, sir.
The third law is a very general law, but yeah, it's very interesting law. We'll discuss this law in more details more next time. Are there more questions? So let us take new candidates. Here is what? Hello, Saksham, you have any question? So Saksham has put a Mithila Digital World,
Yes, sir.
and we have. Let me just put it on the stand, then I can see it properly.
Good evening, Amarnath Sir.
Good evening. Please continue.
Yes.
Yes, sir.
Uh, are there some more questions?
Yes, sir. I had a few questions.
Yes. What is that? First,
So,
Aryan, you must give priority to the things that you are learning in school and things which you are.
sir, we
Yeah.
my schools haven't opened yet.
No, no. Whatever you are learning, no. So what will happen is that so other friends of yours who are in this, no, they will also get benefited. You will take all questions, whatever mind comes in your mind. But
So, sir, my question was about
yes,
the double slit experiment. Uh,
double.
double slit experiment.
Yes.
First, when we did that, it revealed interference patterns. But
Hmm.
after, and if we don't observe that, like the other setup was, we get we shoot out individual photons from the slits, and then
Hmm.
it will give two columns, which means that light is a particle. So, how do we isolate a photon? Uh, how do we do that?
No, no. You said that. So
Yes, sir.
I don't know the technology behind it. I don't know the technology behind it. But the photon part, when we talk of photon, we are talking about the particle nature of the light wave.
Yes, sir.
Yeah. So, so like say, there is an experiment. There was an see the double slit experiment proved to us that light is a wave, which we didn't know. So light is a wave. That's fine. So therefore, there is an interference pattern. Fine. Now, and there was another experiment which was by someone else. I don't remember the name, but Einstein explained that that is photoelectric emission experiment which was there. So from that it proves that the the light is a part. It constitutes particles. These are
Yes,
two experiments, and of course, then there were many experiments. There were, in fact, now people have done with a single electron, which they are bombarding the two slits with single electron. So they find that there is an interference pattern comes. Now, sorry, I forgot you what the question was then. Aryan, hello, Aryan.
yes, sir.
What was? No, are you satisfied with this answer?
Okay, sir. I had one more thing to ask about these photons. That
Mhm.
how does nature benefit from the duality of these particles? There should be any reason, right?
The word benefit is a human word. There is no, there is nothing benefit. The world is not based on the benefits. The world is
Like,
based on the laws of the nature, and whatever has been created. So whether it is beneficial or not beneficial is not an issue at all.
sir, like there's a principle that objects tend to be at their lowest state. So there's a cause for these things. So, like I use the word benefit to ask for this cause. What's the fundamental thing that's happening that is leading to this?
So, sorry, can you repeat this question once again? Just wait.
Is there anything more fundamental
Just
that is?
1 minute. I'm bringing my table a little bit nearer. Right now, go ahead.
So my question was that, is there anything more fundamental that this duality of the particles arises from?
Oh, this is a very good question, and a question whose answer is not yet known. See, people still think, you see, people like even Einstein and many others, they think that there is some hidden variable somewhere because this world cannot be probabilistic, you know, that a photon is a wave function and a particle at the same time. So it cannot be probabilistic.
Okay.
That is what quantum mechanics tells us. So most people, many people, not most, many people feel that there is some hidden variable that again someday we'll discover something that things will become again deterministic. So this is an open question. There is no answer to this one. But
Okay, sir.
quantum mechanics works. This is taking particle as both particle and wave and then doing calculations, it works, you see.
Sir, uh,
The results which we obtain using quantum mechanics are very, very accurate, you know. See, from quantum chromodynamics, you'll be surprised. You will learn it in future that the magnetic moment of neutron, you can 13 places of decimal can be calculated by theory itself. So that means quantum mechanics works. How it works is a question that we don't. And what
sir,
many people still don't believe. I'm also one of them.
uh, sir, I think that when a particle is in isolation and when it's not being observed, it's like in coding. What happens is that if the graphics, if there's a place far away, the computer does not load it. It just it's a pretty blur, and when we get close to it, it becomes clear. So it's like that. So this is what I think of this particle duality.
The particle duality is that it is both a particle and a wave. That's what it is so
Sir, but
simple as that. So
sir, but
it behaves
since
as particle, it behaves as wave both.
yes, but
So,
they act as waves when they are not being observed. So when they are in isolation, and there are many things that uh, come in the category of being observed is like thermal heat, reacting with thermal heat, many more things. So most of the things are particles that we see, and the particles become waves when they are not being observed and they are in isolation. So
no, Aryan, the problem is like this, that if something is a wave, so you see what is the problem which physicists are facing, that if something is a wave, that means it can exist here, there, and in a narrow space, it can exist anywhere.
yes,
And
sir.
then when it behaves like a particle, no, when you try to find it out where it is, you localize it at a one place. So it has, so they call it by, they use the word collapsing. The wave function has collapsed to a single point particle. But these are
Okay,
the
sir.
things, you know, philosophical things right now. I mean, the interpretation is yet to come, something which will satisfy everyone. Maybe you might find someday. Why not?
Oh,
I myself believe that someday we'll find a deterministic way of things because things are not moving randomly. There is a certain law it's following in a very precise way.
so sir, you don't believe in free will?
Believe in?
Free will, the ability to do things on our own.
Oh, that's a very big question you are asking me, you know, but I believe in free will, but whatever the Lord suggests, that there is no free will.
Sir, but there are
These are very big questions, and I
yes.
don't think any day it will be resolved.
Okay, sir.
Sir, I have a question.
Sure, sure. Your voice is very nice. Please ask.
Sir, may I ask right now?
Yes, sure.
I was raising hand for a long time. That's so natural.
Hmm? Well,
Natural
please,
and artificial magnet.
yeah, please once again. Sorry. What is an artificial magnet?
Natural and artificial magnets.
Sir, she is asking about the difference of natural magnet and artificial magnet.
Oh, of course, the word artificial itself means that one which man creates. And then there are magnets found in the earth itself. Magnetic properties are there. You see, आज से 500-600 वर्ष पहले जो कंपास यूज करते थे, so they used to get from the earth magnets. उससे magnetic needle बनाते थे. Those are natural
So
magnets they were using. And
natural
how to
force
make
के natural force के example magnetic force.
Mhm.
Na-
What is that magnetic force?
So magnetic force are two type of, and so then what is magnet? I say magnet. Magnet has two poles, north and south pole. North pole attract south pole and south pole attract north pole. And
Mhm.
north repel north pole and south repel south pole. मतलब same pole are repel and opposite pole are attract.
Right.
AI made sorry, artificial artificial magnet made by human. Example cylinder
Hmm.
magnet.
Or we can say neodymium magnet, etc.
Yes,
Uh,
neodymium, the gallium, there are many kinds are there.
yes, sir.
We can also create
They
magnet
behave, they behave in
by
the same way. Acha, the one permanent there is something called permanent magnet. Are you talking about that? There is
Sir, can
something
I
called,
ask a question right now?
see, there are magnets, like say आपके fan में जो है ना magnet जो लगा हुआ है, those are वो जो ही करंट चला जाता है उसका मैग्नेटिज्म भी चला जाता है.
Sir, I have a
But there
question.
are permanent magnets, that even if it is by birth itself, it has got magnetic properties. Because the domains are aligned in a particular way in the natural magnets.
Sir, I have
Sir,
a
can I
question.
ask a question?
Acha, okay. So, no, he is raising his hand since a long time. Yeah, go ahead with Sakshan. Go ahead. You're raising your hand since a long time.
Yes, sir. I had a question that we know that snow forms due to ice forms due to the water, and it can turn into snow, right?
Sure, yes.
Yes, but in other planets, like especially on the dwarf planets like Pluto, there are lots of methane gas in it, and that methane gas turns that snow into the red color. So, how does methane is able to turn the color of that snow into red?
Oh my God, I really don't know the answer of this question. Someone knows this answer to this question?
That because of its chemical properties, uh, they react with the snow, and as you know, the electrons, the other things. What happens is that it will after that the material formed will reflect red the most and absorb the other colors. So uh, that is one of the reason it can turn red. It's because of the chemical properties of methane and snow.
Oh, yeah.
And
Okay, I will check this answer and then come back next time.
okay, sir, and
Thank
I
you.
have
Thank
one more
you.
question that we know there are four fundamental forces. Strong
Hmm?
force. So, sir, I have one more question that we know that there are four fundamental forces.
Which
Strong
are
force.
which are those? Do you know that?
Yes, sir. Strong force, weak force, magnetic force, and gravity.
मैग्नेटिक माने इलेक्ट्रोमैग्नेटिक फोर्स एंड
Yes,
ग्रेविटी.
yes, sir.
अच्छा, आपके बॉडी में है क्या स्ट्रॉन्ग फोर्स अप्लाई होता है?
हाँ सर, पार्टिकल्स में जो एलिमेंट्स होते हैं जैसे पार्टिकल्स में आप बोल सकते हैं स्पेशली इन एटम्स there are you can say I don't remember the name right now the particles of atoms are joined together due to the strong force. That's
Right.
why we are stable.
Yes, and weak force भी होता है आपके बॉडी में.
That was sir my question. Weak force I think sir शायद होता है. Particles के अंदर weak force भी present होता है.
वेरी करेक्ट, वेरी करेक्ट. आपके बॉडी में जो है ना, जो एटम का जो न्यूक्लियस है, उसमें स्ट्रॉन्ग फोर्स भी काम करता है, वीक फोर्स भी काम करता है. वीक फोर्स जो है ना, तो बहुत ही इनफैक्ट आपके बॉडी में जो होता है, अब लोग पोटेशियम खाते हैं तो पोटेशियम में K40 जो है ना, रेडियो एक्टिव एलिमेंट है, उसके कारण आपके बॉडी में पोटेशियम कैल्शियम में बदल जाता है बिकॉज ऑफ द वीक फोर्स. बट इन एनी केस न्यूक्लियस में स्ट्रॉन्ग फोर्स भी है और वीक फोर्स भी है.
Sir,
But
I have
both
a
the forces
question.
जो इन्हें
So
एक
sir
चीज ध्यान में रखिए,
so
दोनों
sir
फोर्स
might
जो
be
है ये बहुत शॉर्ट रेंज फोर्स है. ऑलमोस्ट वीक फोर्स तो इतना शॉर्ट रेंज है कि यदि दो पार्टिकल एक दूसरे को टच नहीं करेंगे ना तो फील ही नहीं करेंगे.
okay sir. So my main question was
यस.
why don't we see strong force in a major amount like we see gravitational force in a major amount like near stars and almost near every object, but we see strong force only near the particles. Why it
या
is?
हाँ, वही हम जवाब दिए आपको कि दोनों ही स्ट्रॉन्ग फोर्स और वीक फोर्स जो होता है तो बहुत ही शॉर्ट रेंज है. By short range, I mean almost say weak force is 10 to the power minus 17 centimeter range है उसका. -17 माने आप सोचिए बहुत शॉर्ट रेंज है वो, तो आप फील नहीं करेंगे. पर ग्रेविटेशनल फोर्स तो बहुत दूर तक फील होता है, इलेक्ट्रोमैग्नेट भी बहुत दूर तक फील होता है. बट ये स्ट्रॉन्ग और वीक फोर्स इतना शॉर्ट रेंज फोर्स है कि आप इसको फील ही नहीं करेंगे. आप
Okay sir.
और देयर इज Akshitas. Hello, please go ahead. क्या हुआ?
Sir,
हाँ, बताओ.
sir, I have a question.
Sure, sure, please.
Write three properties of a magnet.
नहीं, तुम्हारा आवाज क्लियर नहीं हो रहा है, थोड़ा जोर से बोलो ना. Please speak louder. Possibly in English.
Write
Otherwise,
three
Hindi also will.
properties of magnets.
Three, three.
Can you please
Yes,
repeat your question with
I got it.
normally?
Her question is that write three properties of magnet.
Yes.
Oh, what are the three properties of magnet?
Yes, sir. Yes, sir.
Oh my God!
Sir,
What are the
can
three?
I like answer?
Yeah, who wants to
Yeah,
answer that?
the
Please,
rule should
please.
be that anytime any new question
Sir,
comes,
I am also
first
able to answer this question.
senior
Yes.
student should answer it. Yes, go ahead. She's
बोलिए,
asking
कौन
three
answer?
properties of magnet. What
Yes,
are the
sir.
three properties of the magnet?
Like
That's
what
all of my question.
properties like a magnet attracts magnetic materials such as iron, nickel, and cobalt. And so, like a magnet have two poles, south and north pole. Like poles repel each other, while unlike poles attract each other. Like north to north pole repel, south to south pole repel, but when we do like north to south pole, it attracts. Yes, sir.
Very good. Are you satisfied?
Uh, I'll just ask a small question in this.
Oh, Uday ji,
Attraction can
welcome. Welcome.
attraction
You are
can also happen between a magnet and a non-magnet, um, magnetic but non-magnet, like a iron piece or something. So does the iron piece becomes a magnet in that case?
Or it can become, but I don't think so. With just one small interaction, it will.
No. So why I'm saying is it's not the force of attraction. It is actually a property of attraction. It's the property of repulsion that makes it a magnet. Only a magnet can repel another magnet, but a non-magnet can be attracted towards a magnet. So that attractive property is there, but it is because of the repulsion. The repulsion only decides that both are magnets.
Hmm. Yeah, yeah, very nice. Thank you, Uday. There is one more interesting property of the magnet. If you change the magnetic field with time, it will generate electric field. How interesting it is.
Well, let us just continue with the simple answers. What are the top three properties of magnet, class? I think we got about attraction and repulsion. What else? Because she's class 2 or 3 student, so we have to answer her. Think about it. How can you explain to her?
And there is a small kid here, so she has changed her background also. She knows how to change the background. Oh, she's changing her face also.
Huh?
She's changing her face also.
Oh, Akshita. Okay. Nice. Okay, so you guys can answer other two properties of magnet. We want to see if we can think about simple properties. Saksham, Aryan, other than the attraction, repulsion, what else it do? It does. Does it help you in finding the direction?
Sir, sir, magnets are capable for producing electricity.
Okay. All right. This is the higher level. I was hoping for simpler level. Do you think magnet can be used for direction, finding the direction, north, south?
Yes, sir. We use yes, sir. Travelers use a magnetic compass for finding the direction. If the magnet is tilted towards the north or south direction, they will move towards that direction.
Okay, so Akshita, here you go. You got the three answers, right? Attraction, repulsion, finding the direction, which one is north, which one is south. And third is that we produce electricity using it.
Yes, sir.
Another property is polarity. That if there are two magnets and if they face each other, if they repel, they are of the same pole. If they attract, they are opposite poles. So by direction, you can find out which is north, which is south. So magnet will always have two poles, and the direction, the way to find out the which is north and south is if you freely suspend them, they will be facing north south. And between two magnets, if they repel, that means they are of the same pole.
Okay, good. All right, class. So I have a homework for you guys. So can I share my homework, which I have prepared for you guys to think about and come back and answer to us?
Yes, sir.
Are you ready? Are you ready for it? So let me
Yes.
define the problem. The problem is in right now we are facing very tremendous heat everywhere, right? And uh, there is a natural cooling method which was used in ancient time, and we were not fully able to utilize it. So the homework I'm going to show you is uh, how to utilize the, you know, our underground cooler temperature. If you go beneath the ground 6 feet or 8 feet, the temperature there doesn't matter which part of the world you go. The temperature below 6 feet of the ground and lower is 50 degree or lower, and it keeps going down and down. So we know the temperature under the earth is 50 degree or lower after 6 feet. down. So the question is that if we can use the air circulation in a way that we circulate the atmospheric air through them, bring it to our home, we can naturally cool our homes. But we are not doing it. So that is the homework. I want you guys to think about it, how practically we can do it. So let me share it with you. I have put together a small presentation of the different videos, which you have to, homework is that you have to study all those videos and some more on the YouTube. And then you guys will collectively come up with a plan. How can we naturally cool homes in Madhubani, Darbhanga, Delhi, Patna, Hyderabad naturally without using electricity, or maybe even using simple fan or minimum electricity. So let me share with you the presentation, and then you guys can tell me what to do.
I'll
One,
I'll just add one thing. It's 50-degree Fahrenheit, so they
okay,
must
okay,
so
yeah,
they must
50,
say 10 degrees
50,
Celsius.
yeah, sorry, okay, yeah. So Fahrenheit 50 degree. We corrected it. See, we all do mistakes.
Yeah.
So, okay, so here you go. This is a good project for all of you. You know, you can solve a big problem of India if you guys can figure out this one. And okay, now it's coming good. So let us start here. Are you guys able to see my small presentation? Okay. Yeah.
Yes,
So
sir.
homework for Saturday class, science class: cooling houses with cold 6 feet underground air. Okay. So here I'm giving you all the videos and then also the YouTube link. So in the first one here, you can see here Earth Air Tunnel. You click on this one, and I'm going to send it to the class here to
Sir,
Pankaj to
can you
share with
repeat
you.
the first
So
picture?
so you can see that above temperature is 30 degrees Celsius, below is 24 degree, and how to utilize it in this video. Second one is the same. This one is also. Third one, if you go here, they are giving us some example of how the air dynamics works. So you can use that. Fourth is this guy has made his method of cooling the house. Okay. This is another system here. See here showing us that it's he is showing you the pictures how he has done it. So it's not that some people have done it. Some people are doing it already here and there. But my question
So,
is
sir,
that how can
you
we make it a part of the design of the house? That when everybody may build a house in, say, Madhubani, Darbhanga, Patna, Bombay, this have at least, I can understand that big, like multi-story building, we may not have enough cool air to utilize. But a single story house, a small house, I think we can use it. So this is the homework for you guys to think about it. And can I expect a presentation from you guys? You guys can talk to each other. This is what it will show us, that you can work in a team, because engineers and scientists, they work in a team to solve the problem. Nobody alone works in an isolated cube or office and make a big discovery. That only some theoretical physicist like maybe Einstein did it or Newton did it. But in the modern world, the rule is that science is so complex that nobody knows the whole thing. So you have experts of different fields, and they put their head together to solve the problem. Everybody looks at from different angle, and then they come up with the answer. So you are 5 6 very good science students. So you guys have to figure out how to make it useful for the society. That will be a big benefit to the society if we can figure out the cooling system. Okay. So this is the homework. I'll ask Pankaj to send it to all of you. Back to you, Malik ji.
So, Amarnathji, I had one question about this project. Has
Yeah.
someone made it already?
Oh, yeah. There's here and
No,
there. I was looking at the YouTube. You can also look at it. I see
no,
that some people are utilizing it.
sir,
And
I
then,
have
no,
related
basically,
to
he is dumping the heat of the house
yeah,
below.
yeah,
Basically, he is dumping the heat below. So after some time, the 6 feet नीचे तो गर्म टेम्परेचर बढ़ जाएगा उधर.
No, 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 no. So that's what it is. That when you go below the, let me see if I can find a right picture here. Where, let's see in
Unless
the
you
top.
have many tubes going through the ground bottom.
So basically, what it is that you need a length. Yes, you are right about that one. So basically, what they do is that underground below 6 feet or 7 feet, they they dig the land, and then you can do two ways. You can have a curved like a circular tube and wind it. That's one way. Or you can keep a length, a big length. You need at least 20-30 meters of length, so that the hot air from the house is coming down, and you have to come up with a mechanism how can you push the hot air down. And then in this wire of say 30 meters, which is submerged in the cold air, when the air is blowing, and you have to calculate that how long you need depending on what is the size of your house. And so when the hot air goes through this pipe underground, gradually it keeps cooling as it goes to the exit point. And by the time it goes to the point, it's very cool at your temperature, whatever you desired temperature, you can figure it out. And then that air, cold air, you pump to your house. That's all is the mechanism.
No, that is fine, but basically the whole mechanism is dumping the heat below the ground.
Yes, yes.
Yeah. So that dumping, that suppose I dump it, let us say in the daytime only, and what happens is that the temperature after some time, say 2 hours or 3 hours, it will get hot below, isn't it? Anyway, that gentleman has proved it, so I think.
No, no. You didn't get the point. So the air is circulating. So hot air is coming. Your length underground is so big. You have to calculate how long is what should be the length of the underground piping area. That air, hot air which comes down, goes there gradually over the time. When it passes from the entrance point to the exit point, it cools down because it is surrounded by the 50 degree 55 degrees Fahrenheit temperature there. So
हाँ,
it has.
fine. बट हीट जो है ना कहीं पर तो डंप होगा वो नीचे में.
So heat is absorbed by the atmosphere there, 55 degree below, whatever is the ground air, that will, earth will absorb it. Clay will absorb that heat.
Let our children इस पर माथापच्ची करें.
Yeah. So, and imagine if we can solve this problem of India, how much benefit it will be. I was looking at some of the pictures. I said, "Oh, this is very good homework for students." And maybe some of them, rather than working on the space physics, you guys can solve the real-time problem. And if you guys do, we can give you a project to do it. Find a house. Maybe Malik ji can put a project in Sripati someplace. Will you practically you build a system there? Go and build it. Summer project. Uday, you want to add something in this physics, how it works, so that they can get some theoretical?
No, okay. I have not seen this particular thing. The only thing that comes to mind is you have to have a long pipe through which water air is circulating underground for sufficiently long time for it to cool down to that temperature. And
exactly. That's what is the key. That is what is the key.
And it can be done the other way around also. It can also be done for heating. Like for places like United States where it's too cold in winter, it can be done the other way around. It can be used for heating the house because the actual temperature is way below 50 degree Fahrenheit. So even if it brought up to 50 degrees, it will save a lot of energy.
Oh, sorry.
Hello, Akshita. Akshita, please. Yeah. Concentrate on what your teachers are telling you.
Okay, sir.
Yeah, because the nice pictures that you are showing, I am getting distracted.
Okay.
Yeah.
Okay, kids. So we give you a couple of weeks to read and come up with the physics behind it. It's very simple physics. This is heat exchanger, we call it. It's a part of the physics. It is what you are trying to do is that manipulate air temperature, right? And then you are coming with a kind of utilizing earth as a sink, uh, heat source. You dump it into the earth and earth will absorb it. So you have to come up with also that material of the pipe should be such that it can easily transfer energy from inside of the pipe to outside to the earth, to the clay. If say for example, it should be a conductive, heat conductive type of material would be much better, because easily then inside heat will be transferred to the outside clay.
And it actually is
So,
two way. It's not just in summer. Like in India, it's always going to be summer. So in India, it's going to be cooling the house. But in
Yeah,
places which are cold, it can work other way around also. It can
yeah,
also be used for heating the house. Like,
exactly.
yeah,
So
like
yeah, I mean, in some, even in our part also, we need at least heating for 2-3 months. In Bihar, everywhere we need. So you come up with a system that for 8 or 9 months you use to cool the house, and 2 months to heat the house, free, very, with the minimum charge. Imagine how much energy we'll save in India. We have shortage of energy right now, and in fact, right now we don't even have the air conditioning in many houses in India, right? So if we can do with basic manipulation, if you can help the society to cool the air, imagine how much help you are doing to the society.
Udayji,
hmm, yeah.
yeah, Udayji, I
Um,
think
uh-huh.
our bright young scientist Aryan is asking this question 2-3 times.
What's it?
The question about free will. What is your opinion about it?
Okay. So yeah, I heard that question. I was this thing. Now uh, they talk. I'll give example regarding meteorology. They say that meteorology is a perfect science, but number of variables are so many that we cannot factor them. So even something is happening, it is happening in a deterministic manner, but there are so many factors which affects at any given point of time that there is no way we can factor everything. So in United States, whenever there is a hurricane which is coming, there are some 100 different lines, because there are different models and different models uses different factors to different degrees. So the prediction is all over the place from Florida to Georgia, so it can go anywhere. As they come closer, they become more predictable. So when we talk about probability, deterministic is very difficult to find. Things happen in a particular pattern. Same set of conditions have to exist for things to happen. But at any given point in time, a lot of factors are affecting us. It's not just one factor that affects, like gaining weight. It's not because we eat a lot we gain weight. We gain weight because we eat a lot. We eat different food. We eat different quantity of food, different type of preparation, the genetic factor, the lifestyle. So anything in life, there are so many factors that is very difficult to call them deterministic, because we really don't know why it's happening. Two people, same thing, everything same, will have a different health outcome. Eating everything same in the house. So that is probabilistic. Why it's happening, we don't know. There are so many factors. One of the factors must be triggering it.
Yeah, to make the same question in another manner, what probably Aryan is asking that हम लोग जो पूछते हैं, is it that it is done by the chemicals in our brain which is making us think, see, analyze? There is no control on it. It is the thing there, or is it that there is something that I am doing it? I am
So
thinking about it. So that is the
so
question.
thing
And
is
what you
the
said is
concept
very
of
correct.
artificial.
What you said is very correct. That things are not predictable because we have got too many parameters. That's very correct. But he's
So,
asking a fundamental question that do we have a free will or everything is deterministic?
okay, so now I'll talk about the brain part of it. Okay, now the two are actually, what I'm trying to say is inseparable. Though, like I'm saying that, let's take a brain part of it. The concept of artificial intelligence has come out of the brain. So it's not only the machine is getting trained, our brain is also getting trained. So how does our brain get trained? Brains are trained based on the sensory organs that we have. So based on what we see, based on what we feel, what we hear, we perceive things in a different way. So there is a gap between the eye and the brain. So brain is actually every time evolving itself. It's trying to learn new things, change perception. And because a person keeps changing his perception, they see things based on their perception. So what is happening, what a person sees, what a person, like same thing, uh, depending on the angle you are seeing, is going to look different to you. That is perception. So what I'm saying is, there is nothing free will in this particular sense. No one is actually thinking free. No, there is no free thinkers. Person is thinking based on his perception, and the perception is built based on his past experience, which he has perceived through five sensory organs, which he has sensed through five sensory organs. Did I answer that thing?
No, so where is our Aryan? Where he has gone?
Uh,
Sir, I have a question. Can I ask?
Okay,
okay,
ask.
Okay, sir. My question was, does a void can exist inside a void?
sorry,
Does the
My question is, have you heard about the voids?
voids,
voice,
Yes, sir,
audio.
voids.
voids inside a
Yes, sir. So my question was, can a void could exist inside a void?
Can you spell it?
Saksham, I really can't answer this question.
Can you
Udayji, you
spell the
want to
word
make an answer?
void?
VOID void.
Or that means nothing exists.
Yes, sir. What did you say?
No, you are saying, does void exist in void?
Yes, sir.
Void is empty.
Yes, sir. That I know.
So what you are trying to ask in that particular case?
Sir, my main question was, I have heard that the Milky Way is inside the KBC void, which is 2 billion light years in diameter. And Milky Way is also relatively close to its center. But there is another void known as a local void, which is 200 million light years in diameter, sits relatively close to the Milky Way galaxy. So this means that the local void sits inside the KBC void.
So okay, so in case of cosmology, void is basically empty space. Okay,
Yes, sir.
so there will be and any empty space is called as void. And I actually, there's another thing is, we really don't know they are entirely empty, because there may be something which we don't see or we are not aware as on today. So there may be some faint star galaxies, some faint star moving from one. Stars also keep getting attracted and pulled from one galaxy to another. So there could be something in transition. A group of stars must be there. So there could be a lot of things happening there.
Yes, sir. So what I have heard that the Milky Way is relatively close to the local void. So what does it mean? Means the Milky Way is near the center. So does the local void is a different void from KBC void? So does that mean the local void sits inside the KBC void, or do they are same?
So, so saying in general, I don't. know about individual voids, but generally voids are empty space, and there are galaxies, and between galaxies there are voids.
Yes, sir.
Okay. So what the empty space is basically void, which we are.
Okay, sir.
Hello, are there some more questions?
So Aryan,
Oh, yes.
Aryan curiosity is over. No, he's gone.
He's gone. So we have only Saksham.
Yes,
So
sir.
Saksham, do you have any question now?
No, sir. But I will ask later on.
Only time.
So I have one question for you, Saksham. Why are you worried about the voids between the galaxies?
What do you mean to ask? Like, what? Why does I'm curious about the voids?
Oh, no. I'm asking, where did you get this question in your mind, actually? In your school book?
No, sir. In our school books, there is nothing about this
You
space.
were reading separately something and there you saw it, is it?
Yes, sir. Yes, sir.
Oh, I see. That's very nice of you that you are able to read books beyond your school things. Yes, you should do that. You should get some books, very good books on many things. But always spend your time in trying to learn the basic concepts in science, physics, chemistry, math, then biology. Basic concepts you must try to learn. Once you learn basic concepts, then you can understand bigger things very easily.
So, sir, I had one more question regarding the cosmic microwave background.
Is that microwave?
Background CMB.
Yeah, go ahead. What is about the microwave?
So, sir, my question was according to the cosmic microwave background, there are two things: walls where the matter exists in abundance and voids, the spaces in between. Means in walls the matter exists in abundance and in voids there is nothing, no matter. But in some voids like our own KBC void, there are many superclusters and clusters. No matter they are relatively small compared to the void, but they are the abundant amount of matter located in one particular place. So why? So this means that the KBC void denies the means it denies the things about the cosmic microwave background, which means that the void could exist nothing. So does that mean that cosmic microwave background is wrong?
Oh my God, Saksham, your question is very hard for me. It's very, very hard for me. Udayji, you want to make any comment on this?
No. So basically, okay. Can you repeat the question once again? What I understood is you are asking about cosmic microwave.
Yes.
That's what the question is.
My question is related to the cosmic microwave background.
Okay.
So it was that according to CMB, there are two things in the universe: walls where the matter exists in the abundance and voids, the spaces between. But cosmic microwave background also says that in voids nothing exists. Means they exist in a relatively small amount, like almost near the zero. But in our own super void, the KBC void, there are many superclusters and clusters like the our own Laniakea supercluster and the Antilla Sextans cluster, which contains dwarf galaxies. So does that mean the cosmic microwave background is wrong? That nothing exists inside the voids?
Okay. So
Okay, there is just 1 minute, Udayji. Saksham, do you understand what is cosmic background radiation? What it
Yes,
is?
yes, sir. It is a small model of the universe. Scientists have created a small model of the universe where it shows the average temperature, and scientists study the whole universe as cosmic microwave background.
No, where from it has come? Who has produced it?
Um, I think, sir, it was produced in 1980s, but I don't remember
No,
that who produced.
it was discovered in there, but where? Why do we see cosmic background radiation? What is where? When was it produced? Where from it has come? See, unless you don't understand that, you cannot understand the next part of your question. So, will you spend some time in trying to understand what is cosmic background radiation?
Yes, sir.
Yeah, you'll. Yeah, Udayji, please continue.
Yeah. So actually, the last time also I was talking about that we are still discovering a lot of things, and a lot of things about cosmology is based on mathematical equation. With every new discovery, our old concepts gets defeated. Like initially, we were talking about universe being static, then it's expanding. Then we are talking about if it's expanding, then Milky Way stars it will not have that spiral shape. Then we said something is holding them back. We call them dark matters. But if that's true, then the age of the universe is just about 13.4 billion light years. But the diameter that we see is 93 billion light years, which is only possible because it could be expanding. So we are learning about it. Now, 95% is dark matter and dark energy. That means we cannot see anything. Then we said, okay, between the galaxies, the empty space, we call them void. Now we discovered something in that empty space. So initially we said there nothing exists. Now we are finding something in that. So we are saying it is under dense. So dense materials we see it as galaxy something inside with improvement in the uh, telescopes and the optics, the optical equipment, we are able to see through those dark places. So when we see through the dark space, we find something. So we are saying it is under dense. That means something which is there but is so little that we are not able to see it based on current technology. So as we progress, we'll see more about it, and more our theory will keep getting revised or modified, if I can say. I'll not use the word revised. That I'm not saying the previous guys were wrong. It's just that everything keeps evolving, and we keep our understanding keeps improving.
Nice, thank you.
Yes, sir.
So, Pankaj ji, hello. नहीं अब एक ही बच्चे बच गए हैं तो